Alright, our next rule is quotient rule. Okay, and the quotient rule, the formula is dy dx equals to v du dx then minus u dv dx all over v squared. Okay, so what we are going to do now, we are going to prove this. So once we are done proving this, then we can go straight to, can take some questions under it and solve. Okay, so let me just write it here so that you have that in mind. So our dy dx is equals to v du dx minus u dv dx all over v squared. Now, how do we prove this? If you're having y equals to u over v, okay, when you add two questions dividing each other, it's written as quotient rule. So using first principle, so this is written as, whenever I differentiate y, it's written as y plus change in y. Then equals, if you differentiate s, u, is written as u plus change in u. Then all over v plus change in v. So what do you do next? There's no way you can simplify further. You may change in y the subject of the formula. So we have change in y equals to u plus change in u. Then all over v plus change in v. Then minus y. Now this time around, our y is written as u over v. So we have change in y equals to u plus change in u. Then over v plus change in v. Then minus u over v. So what do you do here mathematically is to take the what? The LCM. By taking the LCM, we have change in y equals to u plus change in u. Then over v plus change in v. Then minus u all over v. So our LCM is written as v bracket v plus change in v. So this time around, we have change in y equals to, this going to this, they will cancel out, we'll be left with v. So v times everything here, we still have v bracket u plus change in u. Some people might be confused. This is written as v bracket v plus change in v, then divided by u plus change in, divided by v plus change in v. So this can cancel out this, we'll be left with v. So use of v to multiply the numerator. So at the same time, if you are not dividing it with v, so v will cancel out v, you'll be left with this. So this is written as minus u bracket v plus change in v. Then all over the LCM, which is v bracket v plus change in what? V. So this time around, it becomes change in y equals to v times u is written as uv. V times change in u, we have plus v change in u. So we have minus u times v is minus uv. Minus u times change in v is minus u change in v. Then all over the denominator, which is v, the brackets v plus change in v. So this time around, so this can cancel out this. Once it cancelled out, we'll be left with change in y, then equals to v change in u, then minus u change in v, then all over v bracket v plus change in v. So what you do next, we can easily open all this bracket if you want to. This is a change in y equals to v change in u, then minus u change in v, then all over v squared, then plus v change in v. Okay, so from there, this time around, we are looking for dy ds. You divide through by dy ds. So this is stating as change in y over change in s equals to, what you are going to do, everyone with changing, you divide them with what? Changing what? X. So this is stating as v change in u over change in x, then minus u change in v over change in x, then all over v square, then plus v change in v, then change in what? X. Now, what you are going to do is that you limit change in s approaches what? 0. So it's stating as change in y over change in what? X. We stating as, what you are going to do here is that we do not need what? We do not need this. So since you do not need that, you limit it to be what? To be 0. So your final answer, why you are limiting it to be 0? Because it's v change in v over change in x. So what we need, we don't need this. Okay, you can see we are having what? The same variable there. So it becomes v change in u over change in x minus u change in v over change in s all over v square plus 0. So to get our dy dx, it becomes v change in u over change in v du dx, then minus u dv dx, then all over v square. So that is for that. You can see it's the same thing with this. So this time around, we are going to take question under this quotient rule using this very word formula. All right. All right. So you are welcome back. Now we are asked to differentiate the following and write in respect to what? X. Now, in quotient rule, don't forget, I say first you do, you assign a variable to them. Okay? And if you share the formula, dy dx is equals to v du dx minus u dv dx over v square. Okay, the parameters we have there, we have v, we have du ds, we have u, we have dv dx. So between u and v, which one comes first? U comes first. We'll assign u to the numerator and v to the denominator. You can simply say let u equals to 2s squared plus s plus 1, and let v equals to s squared plus 2s plus 1. So this time around, our du dx, it becomes, if you differentiate this 4s squared, it becomes 4s squared, 4x plus 1. And if you differentiate this, differentiate v in respect to x, it becomes 2x plus 2. Okay, I believe you already know how to differentiate using the general word rules. That's what we applied here. Alright, so this time around, if you observe, we have everything. I can substitute them into the formula. Our formula is dy dx equals to v du dx minus u dv dx. Don't forget the u is negative, the all over v square. So from there, to get our dy dx, so we are going to manage space. So our v is stating as everything here, which is s squared plus 2x plus 1. Then du dx, du dx is stating as 4s plus 1. Then minus, our u is stating as everything here, 2s squared plus x plus 1. Then our dv dx, dv dx is stating as 2x plus 2, then all over v squared, which is s squared plus 2s plus 1 squared. Now in quotient rule, no need of you opening up the denominator. Okay, opening the denominator, it will require a very long word process before it gets to the answer. Better still, you just leave the denominator and work with the numerator. Not that you opening the denominator is still wrong, it's still correct. Okay, now to make it easier, just leave the denominator and work with the what? The numerator. So we open up this. So by opening that, we'll use 4 to multiply first before we use 1. 4s times s squared is sitting as 4s cubed. 4s times 2x is sitting as 8s squared. 4s times 1 is sitting as 4x. 1 times everything here is sitting as s squared plus 2x plus 1. Then minus all brackets. 2 will also multiply before this 2 will multiply. 2s times 2s squared is sitting at 4s cubed. 2s times 2 times x is sitting at 2s squared. So 2x times 1 is sitting as 2x. So 2 times 2s squared is sitting as 2s squared plus s plus 1. Bracket close. So from there, all over the denominator, s squared plus 2s plus 1, then square. So I'll use this minus to open up this other bracket. Then, but before that, so this sitting as 4s cubed, 8s squared plus s squared will give us what? 9s squared. So 4s plus 2x is sitting as 6x plus 1. Then using minus to open up everything, become minus 4s cubed minus 2s squared, then minus 2x minus 2s squared minus x minus 1. Sorry, this is going to be 2, not 1. 2 times this, okay, will give us 4x squared. This times this give us this. This times this give us this. Okay, 2 times this will give us 4s squared. Sorry, 4s squared. So 2 times x will give us 2x plus 2x, there plus 2. Okay, so from there, by opening up everything here, we are going to have minus 4s cubed, then minus times this minus 2s squared, minus times this minus 2x, then minus times this we have minus 4s squared, then minus times this minus 2s minus 2. Sorry for that little mistake. We have s squared plus 2s plus 1 all square. So from there, collecting items based on power. For s cubed, we have 4s cubed minus 4s cubed. They can cancel out. Then we can move to s squared. We have 9s squared minus 2s squared will give us 7s squared. 7s squared minus 4s squared will give us 3s squared. Now move to x. 6x minus 2x will give us 4s. 4s minus 2x will give us plus 2x. So we have 1. 1 minus 2 will give us minus 1. Then all over s squared plus 2x plus 1 all square. So that's our final answer. Alright, so let's move that to the next one. So the number 2 question. If you are given y equals to 7s4 plus 11, then all over 2x plus 1. Alright, so we assign a variable to these two. Our u can select u equals to 7s4 plus 11 and v equals to 2s plus 1. You differentiate u in respect to x. So du dx. is sitting as 7 times 4 is sitting as 28. 28s cubed. Then dv dx is sitting as 2. So from there, to get dy dx, don't forget the formula is v du dx minus u dv dx all over v squared. So from there, our dy dx now will be equals to our v is sitting as 2s plus 1. Du dx is sitting as 28s cubed. Then minus our u is sitting as 7x4 plus 11. Then dv dx is sitting as 2. Then all over v squared. Our v sitting as 2s plus 1. Then square. So we give us 28 times 2 give us 56. 56s4. 28 times 1 is sitting as 28s cubed. So I will do this to open up this. So minus bracket 2 times 7s4 is sitting as 40s4. 2 times 11 is sitting as 22. Then all over the denominator 2s plus 1, then square. So from there, this is sitting as 56s4, then plus 28s cubed. So using minus to open up, we have minus 40s4, then minus 22, then all over 2s plus 1, then square. So this time I'll collect lighted based on power. So collecting lightens based on power, it becomes 56s4 minus 14s4. So we give us 42. 42s4. Then plus 28s cubed minus 22. Then all over 2s plus 1. Then square. So that is our final answer. So let's move down to the next question. So we have y equals to s squared plus s minus 2, then all over s cubed plus 6. Alright, so from here, you can say let u equals to s squared, plus s minus 2, and v equals to s cubed plus 6. You differentiate u in respect to x. So du ds is equals to 2s plus 1. So you differentiate v in respect to x, we give us 3s squared. So this time I have to get dy dx is sitting as v du dx minus u dv dx all over v squared. So our dy dx becomes, our v is sitting as s cubed plus 6, and du dx is sitting as 2s plus 1. Then minus our u is sitting as s squared plus x minus 2. Then dv dx is sitting as 3s squared all over the denominator, which is v s cubed plus 6 squared. So from there, we'll open all these two brackets. So s cubed times 2s is what? 2s4. S cubed times 1 is sitting as s cubed. 6 times 2s is sitting as 12x. 6 times 1 is sitting as what? 6. Then minus all bracket 3s squared times s squared is sitting as 3s4. 3s squared times 2 is sitting as 3s cubed. Sorry, 3s squared times s, 3s cubed. 3s squared times minus 2 is sitting at minus 6s squared. Then all over s squared plus 6, s cubed plus 6 raised to power what? 2. So from there, we have 2s4 plus s cubed plus 12s plus 6. Using minus to open all this becomes minus 3s4 minus 3s cubed minus 6s squared. Then all over the denominator, s cubed plus 6 raised to power 2. So this time our collective items based on power. We have s4, s4. 2s4 minus 3s4 is sitting at minus s4. Then move to s squared. S cubed minus 3s cubed is sitting as minus 2s cubed. Then move to square, minus 6s squared. Then plus 12x plus 6. All over the denominator, s cubed plus 6 raised to power 2. So that is our answer. All right. So if we are given y equals to tan x, and tan is sitting as sine over cos. So you have to break this one down first. So our y is sitting as sine x over cos x. So what you do, you can see that it's not quotient or true. You can say let RU equals to sine x and V equals to cos x. So du dx is sitting, if you differentiate sine x, you have cos x. So our dv dx, if you differentiate cos s, sitting as what? Minus sine s. So don't forget, we have dy dx equals to v du dx minus u dv dx, then all over v squared. So this time around, our v is sitting as cos x, du dx is sitting as cos x, minus our u is sitting as sine x, then dv dx is sitting as minus sine x, then all over our v square, which is what? Cos x, cos s square. So this one, cos s times cos s, is sitting at cos square x. Then minus sine s times minus sine s plus sine square x all over cos square x. So this time around, in trig function, cos square s plus sine square s is equivalent to 1. So that is, recall, you can recall that cos square s plus sine square s is equals to 1. That is, wherever you see something like this, you can substitute what? 1. So our dy dx becomes, everything here is sitting as 1 all over cos square s. And 1 over cos square s is sitting as sec square x. So that is our answer. Thank you. So that's all for quotient rule. So in our next video, we'll move down to function of a function. Please hit the subscribe button. Thank you.